This is section 12.2, Statistical Analysis. For our first example, we have a real-world example. Miss Gibson runs 3 miles every day for a week. Here are her times: 30 minutes and 1 second, 30 minutes and 10 seconds, 28 minutes and 4 seconds, 29 minutes and 19 seconds, 29 minutes and 55 seconds, 31 minutes and 40 seconds, and 32 minutes. So when information is represented, this is represented as time, and all of this information is represented as time. So since all of the data is represented in one specific way, that's going to be called univariate data because the data is in one variable or data type. Looking at how we can represent this data, we have different ways we can do this. And each of these ways is going to help us find the measure of central tendency, or the number that represents the middle of a set of data. And there's 3 different ways that we can describe this data or use that measure of central tendency. The first is by finding the mean. And you guys are used to this. This is when we add up all of the terms together and then we divide by the number of terms that there are. This is best used when there's no outliers. So in this case, when we're looking at all of these numbers are all pretty close to each other. And so there's not really any outliers. There's not one day that it took her a whole hour to run. All of these numbers are pretty close. Then we look at median. And when we talk about median, we're just looking for the middle number. And that means the middle number when they're lined up in least to greatest order. There could be 2 middle numbers, and in that case we'd add those 2 together and divide by 2. And we're going to be able to use this one, or we're going to want to use this one, when there are outliers, but there's no big gaps in the middle. So maybe on this set of data, if there was one that took her 50 minutes, then we would use median because there would be an outlier, but there still wouldn't be any gaps in the main set of data. And then we can also use mode, which is when we find the number that occurs the most. So if there's a number that maybe she ran, and I guess we don't have any on this one, but maybe she ran on 2 different days, she ran it in 28 minutes. If that were the case, then that would be the mode because it would show up the most. And we're going to use this one when the data has many repeated numbers going on. So in the example below, we are going to figure out which measure of central tendency best represents the data and why. So it's going to be really important that we understand this best used when. Okay, so we want to look at the data and see, okay, which one does it go with here? So in example A, we have 22.1, 21.5, 22.3, 22.8, 23.1, and 20.4. So in this case, all of these numbers are pretty close together, and so there's not any outliers going on. So right away, mean looks like a pretty good one for us to use because there's no outliers in the data set. For median, we are not going to use that because it says that there are outliers, and in this case, there aren't any. And then we're not going to use mode because this says that something repeats a lot, and in this case, we don't have any numbers that are repeating at all. So in this case, we would use the mean. Looking at B, we have the numbers 16, 17, 15, 17, 12, 16, 16, 15, 2, 18, 18, 18, 40, 16, 48, and 1. So here we do have some outliers. So right away we know that we're not going to use mean because mean says that we're going to use that when there's no outliers. So then we have to decide, are we going to use median or are we going to use mode? Now if we used mode, we have 3 18s that appear, we have 4 16s, we have 2 17s, so we have a lot of numbers that repeat more than once and there's not really a clear answer. But if we talk about median, there are some outliers. 40 would be an outlier, 48 would be an outlier, 1 would be an outlier, 2 would be an outlier. But with all of the other middle numbers, there's not really any big gaps between those. So in this case, median is what we're going to be using. A parameter is a measure that describes a characteristic of an entire population. An example is if we're going to be talking about the mean income of the United States. So we're talking about the whole population. A statistic is a measure that describes a characteristic of a sample. An example of this would be finding the mean income of people that live on your street. So that's just a smaller amount of people that we're going to be looking at. In example 2, we're going to determine whether each of the following represents a population or a sample. Example A says the company has each of its employees complete a survey on commuting habits. So in this one, we want to think, okay, is this representing all of the company, or is it only representing a portion of the company? And this actually says it has each of its employees complete the survey. So this one is going to be population because it's talking about the whole company and everyone's going to be taking the survey. And then example B, it says every 5th table in the cafeteria is interviewed to find out what students eat for lunch. So in this case, we're not talking to every single student, but instead we're just talking to every 5th table. So in this case, this is going to be a sample. So if we were actually in class, we would do this real-world example and see what people would vote for as their favorite kind of candy bar. Now, since we're just doing notes here, I'm going to go ahead and just make up a scenario for us to go over. So I'm going to say that 5 people say Snickers is their favorite, and 6 people say Reese's are their favorite, and 4 people say, I don't know, Milky Way. So if we have this information, and I were to ask you a question such as, what percent of the population in this class, or what percent of our classroom likes Milky Way the most, we would represent that by saying 4, because 4 people like Milky Ways, over the total number, which is going to be 15. And so if I converted that into a percent, I'd get about 27% here. So the problem with this is that there's something called the margin of sampling error. So with this 27%, this is representative of our classroom, but that doesn't necessarily mean it's going to represent the whole school or the whole U.S. So the margin of sampling error actually provides the interval that shows how much the responses would differ from the whole population. So when we're looking at the margin of sampling error, we can represent that error as plus or minus 1 over the square root of n, where n is just a random sample taken from a population. So we're going to be using this in example 3. Example 3 says in a random survey of 2,148 people, 58% said that football is their favorite sport. A wants to know what is the margin of sampling error, and B wants to know what is the likely interval that contains the percentage of the population that claims football is their favorite sport. So for A, it's actually just simple. We're just going to use the formula. So we're going to have plus or minus 1 over the square root of n, and in this case, n is going to be 2,148 because that's how many people were actually surveyed. So then if we go ahead and simplify this, we're going to end up with plus or minus 0.0216 as our answer. This is pretty small. I mean, only about 2% of the sampling error here, and that's it. It's going to be because they surveyed so many people here. Now, if they had surveyed only like 10 people, the margin of sampling error would be a lot bigger. So for B, when it's wanting to know the interval, we're going to go ahead and take what they originally gave us. So they gave us 58% originally, and if we write that as a decimal, we have 0.58. And we're going to set up 2 separate equations. Now if you notice, this margin of sampling error has a plus and a minus. So in one case we're going to be adding, and in the other case we're going to be subtracting this number that we came up with. So 0.0216 in both cases, just adding in one, subtracting in the other. And we're going to end up with 0.6016. and 0.5584. So we have 0.6016 and 0.5584, and so the likely interval that contains the percentage of the population that claims football as their favorite sport is going to be between 55.84% and 60.16%. And that's going to be our final answer.